So, what we're going to be doing is learning about organized counting. In particular, we're going to be talking about tree diagrams right now. So, let's have example 1. So let's say we have cupcakes. And we're going to say that the cupcakes come in 3 base flavors, so what the cupcake is made out of. And the 3 base flavors are going to be vanilla, chocolate, and strawberry. Not sure why anybody would like that. And we'll say that there are 2 types of frosting. So 2 types of frosting. So the frosting is going to be either blue frosting or purple frosting. And so the question is going to be, how many different types of cupcakes can be made? Oops, that is totally off the screen. Cupcakes can be made. So pause the video and see if you can figure out the answer for yourself. So what we're going to do is we're going to draw a tree diagram. And the way we're going to draw every tree diagram is we're going to start off with a dot. We're always going to start off with a dot. Then what we're going to do is we're going to look at our choices. Now our choices were, so our first choice is, we have the choice of the 3 base flavors. And in particular, if we do one, we're not going to do the other. So it's a bunch of mutually exclusive choices. So our choices are, it's going to be vanilla or chocolate or strawberry. Then what we have is we are going to have the choices of frostings, and the frosting could be blue or purple. So it could be blue or purple, blue or purple, and it could be blue or purple. And that's the entire tree diagram. And now when we look at the tree diagram, how do we actually count using the tree diagram? Well, every tip of the tree, so that's a tip of a tree, so we have 1, 2, 3, 4, 5, 6. Each of those tips is an option, and we could actually read them off. So for example, if I asked you, what is this one over here? That's a chocolate cupcake with purple icing. This one over here is a strawberry cupcake with blue icing. And that's a tree diagram, so the total would be 6. So there's going to be 6 different cupcakes. And we call this a tree diagram because it kind of looks like a tree, right? There's some branches and then some more branches coming out. It's a tree. Okay, let's do another one. So example 2. So let's say we're going to have shoes. So we're going to have shoes and we're going to have different types of pants. So the shoes would be boots, Crocs, sandals, or we'll just stop with that. And with pants, we could have jeans, khakis. Oh, it's a fashionable choice. Shorts. And maybe flare pants? Flare pants. I think those are things. Oh, should have that in a different color. That's okay. So I want to know how many outfits you could have, assuming. So how many outfits how many outfits, and the assumption is going to be we're going to have one pair of pants, one type of pants, and one type of shoes. So we're not going to wear shoes on top of shoes or pants on top of pants, because that would be a little silly. So what we're going to do is we're going to draw a tree diagram. The tree diagram is going to start with a dot. And then the first stage is going to be the shoes. So we could have boots, Crocs, or sandals. So we could have boots, Crocs, or sandals. And that's our first choice, right? Our first choice is the type of shoe. And then the type of pants is going to be another choice. And if you have boots, you have the choice of, we have 4 choices, right? We're going to have jeans, khakis, shorts, and type of flare pants. Right? Because there's 1, 2, 3, 4 things. So jeans, khakis, shorts, flares. Jeans, khakis, shorts, flares. And it's already getting a little bit unwieldy, but we could actually figure we could work with this anyway. And so what do we see the answer is? So we count the tips. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It looks like there's a total of 12 choices, right? And I could point to any tip, and I could tell us exactly what it is. So this one over here would be someone wearing Crocs and khakis. I'm not even going to try to draw it. And there we go. So there's a total of 12 choices. Now, drawing tree diagrams is might get a little tedious after a while. But I want to show you something. So what we could see is that we had 3 choices for the base, and then 2 choices for the toppings, and then that gave us 6 possible options. And here we had 3 types of shoes and 4 types of pants, and that gave us 12 choices. And in fact, what we could see is that if we multiply it, 3 times 2 is 6, and 3 times 4 is 12. And that's how a tree diagram works. You take each choice, you take the number of options, you multiply it, and that gives you the total number of unique options. Okay. Let's get dressed again. And we'll have an example 3. So we're going to say that we have 8 choices for shoes. So many options, maybe just different colors. 4 different choices. 4 choices for pants. 3 choices for shirts. And 1 hat that you may or may not wear, depending on how you're feeling. So we're going to go draw a tree diagram out of this. So we're going to start off with a dot, and we have 8 choices for shoes. So 1, 2, 3, 4, 5, 6, 7, and 8. And then we have 4 choices for pants. So for each of those we have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And now for each of those, we have 3 choices for shirts. So for each of those, we're going to have 1, 2, 3, and this is getting a little bit crazy. So a tree diagram, it's good to think about things in a tree diagram, but actually drawing out a tree diagram is really actually not that great. We're not going to draw out a tree. We're generally not going to draw out a tree diagrams. We're just going to imagine the tree diagrams. And that's what we're going to do. So what we know is that we have our shoes, and our pants, and the shirts, and the hat. And how many choices do we have for each of these? So let's see. For the shoes, we had, going back to the example, so we had 8 choices for shoes, and 4 choices for pants, and 3 choices for shirts. Now for the hat, we have 1 hat, but we could wear it or not wear it, so we actually have 2 choices for the hat. So putting that all together, 8 times 4 times 3 times 2. 8 times 4 times 3 times 2 is 192. So there's 192 different options for getting dressed. Now let's say instead I had said that you don't have a choice. You have a hat and you have to wear it. How would that change it? It would have made that a 1, and we would have had only half that much, so we would have only had 96.